to have a problem-solving activity about photoelectric effects. But before that, let us first have a short review about photoelectric effect. Photoelectric effect occurs when a certain metal ejects or emits electrons after being exposed to light. These ejected electrons are also known as photoelectrons.
The amount of energy that the light has is equal to the product of the Planck's constant and the frequency of the radiation, or the product of Planck's constant and the speed of light divided by the wavelength of the light. The energy of the incident light must be greater than the threshold value, which is dependent to the metal. The threshold value can be calculated by multiplying the Planck's constant and the threshold frequency of the metal. When the energy is greater than the work function or the threshold value, photoelectric effect can occur. If we subtract the value of the work function from the energy of the light, we can have the value of the maximum kinetic energy of the photoelectrons. This is also equal to the product of the stopping potential and the electron charge.
Since we are now familiar with the different formulas in photoelectric effect, let us try to solve this problem. For our first problem in finding the energy of the incident photons, we have given a frequency of 6.6 times 10 raised to 14 Hertz. Or, we can use the unit of 1/second. And we're going to find the value of the energy. In order to find the value of the energy, we can use the formula of E is equal to the product of the Planck's constant H and the frequency, where H is equal to 4.14 times 10 raised to negative 15 electron volt times second. Substituting the values for the frequency and the Planck's constant, we will have here 6.6 times 10 raised to 13 1/second times 4.14 times 10 raised to negative 15 electron volt times second. If we are going to calculate this, we will have a value of 2.7324 electron volts, where we are going to cancel the unit per second here and here. For our next problem in finding the maximum kinetic energy of the photoelectrons, we have given stopping potential, which is equal to 3.95 times 10 raised to 18 volts. In order to find the maximum kinetic energy of the photoelectrons, we can use the formula of maximum kinetic energy is equal to the electron charge and the stopping potential, wherein the electron charge is equal to 1.6 times 10 raised to negative 19 coulombs. Substituting these values, we will have we are going to calculate this, we will have the value for the maximum kinetic energy of the photoelectrons of 0.623 coulomb volt, where 1 electron volt is also equal to 1 coulomb volt, wherein 0.623 coulomb volt is also equal to 0.623 electron volt. For the last problem in finding the work function of the metal, we have a given of the maximum kinetic energy of the photoelectrons of 0.623 electron volt and the energy of the light, which is 2.7324 electron volt. The formula for finding the work function is by subtracting the maximum kinetic energy of the photoelectrons from the energy of the light, which is equal to 2.7324 electron volt minus 0.623 electron volt. By computing this, we will have the value for the work function of 2.1094 electron volt or 2.11 electron volt.